Alright guys, for this video I'm be showing you how to calculate concentration of an unknown value using absorption. So basically, first of all, what our samples are Kool-Aid samples that we did during the lab where we had known concentration of Kool-Aid mix within water, and we basically used a spectrophotometer to measure absorption and how much the Kool-Aid absorbed. And we basically found that the stronger the concentration is, the more the absorption is, which we'll go into later. And basically, what we did is we also had an unknown value of Kool-Aid that we basically didn't know how much Kool-Aid mix was in the water. So we tested it for absorption, and we got a value of 1.68. And basically, the purpose of testing the previous samples was so that we can get an estimate of how much concentration or grams it is per milliliter of water, so we get a better understanding of where to wage and put the unknown value of absorption at. So what we would do is we created a standard curve, and this is this graph right here. And within the standard curve, we have the best fit line right here. And this best fit line basically shows us how, as the concentration increases, so does the absorption. And this is helpful because now that we know that the unknown value's absorption is 1.68, then we can go to the graph and we can zoom in and we can go to 1.68 and make a straight line all the way until we touch the graph, or the best fit line. And then once we touch the best fit line, you go down, and that would give you a pretty solid estimate of the concentration of the unknown value. This is only an estimate, so it's not going to be fully right, but it's supposed to be close. So we got about like almost 0.4 grams per milliliter of water. So now we're going to use the linear regression which is right here, this equation right here. We're going to use that to find the concentration, like a solid concentration of the Kool-Aid. So we go and we get the equation. Let's see. Y equals, and I'm around this 46.57 to a 47. X plus 0.035. And from here, you would basically plug in the unknown value's absorption into the y, so you would put in 1.68 equals 47x plus 0.035. So basically, we're going to do some math here. We're going to subtract out the 0.035. So go here, cancel it out. You subtract the same number from here, and you would get a value of 1.6443. And now you have that equal to 47x, so you divide the 47 out of the equation to get the x alone, and you do it to this side too as well. And from there, you get a number of 0.034. There we go. And this would be a much more accurate estimate of what the concentration would be using a linear regression equation. So x equals 0.34, and that's pretty close to what we got on our best fit line estimate. And from there, that's basically all you have to do to find it. It's pretty simple. You just have to learn how to do the math. And, you know, everything kind of has to come together in this too. You have to have other data of other Kool-Aid concentration and absorption values. So you can't just go on with just one unknown value, because then you can't be able to compare it to other known values to wage a concentration. And this is really helpful, you know, to use a standard curve, which is a graph, and the standard fit line to be able to get a fast estimate, and then the linear regression for when you're ready to get the real estimate and then compare it with the easier one. And yeah, this really actually helps scientists because, like like the best fit line, that helps them a lot, because then they could see how different things increase when the x or y value increases or decrease, and it helps them get a better understanding for what's going on in the experiment and the trials.